Hello everyone. In this video, we will focus on improper integrals with discontinuous integrand, but we want to consider the cases that the discontinuity is not at end point. It's somewhere inside the interval. Well, let's just quickly review what we had before. So if the function is discontinuous in one of the limits, if it is discontinuous on the upper limit, then we do find the first the integral from a to t, then find the limit as t goes to b from the left. Or if a function is discontinuous at a, we find first integral from t to b, then find the limit as t goes to a plus. Now, what will happen if a function is discontinuous at a point inside the interval ab? In that case, we will chop up our integral into two pieces, from a to c, from c to b. Now, each one of these are an improper integral. We have to compute each one. If both of them are convergent, then we can add them, and that value is what we have for the value of integral from a to b. If one of these, at least one of these, is divergent, then the whole integral is divergent. We don't need to continue. Okay, let's see these ones in some examples. Here we have integral of function 3 over x squared plus x minus 2. So, well, just see that x squared plus x minus 2 this is a quadratic x sum. Okay, so I can do this and then plus 2, yes? So is defined everywhere but at 1 and negative 2. Okay, and while we look at the interval of the integration, well, we see that, oh, it includes 1. It really includes 1. And well, what does that mean? It means that we have to break this integral into two improper integrals. This will be integral 0 to 1, and then integral of 1 to 2. Yes, and well, whatever we want to do, we have to know what is antiderivative of this guy here. And okay, so this is a rational function. I can decompose it, and if I do that, negative 1, that will 1, and then okay, you can find ab, do the partial fraction decomposition, but what you will notice as this is 1 and this is negative 1. Yes, that way you get 3. So I'm doing some of these things in my mind without writing down, but you know partial fraction, how does that work? Now, if you know that, then this will give us ln of x minus 1 minus ln of x plus 2, or just simply, yeah, that's good. That's good. Now, let's try the first integral, 0 to 1 of 3 over x squared plus x minus 2 dx. We know that at 1 it is discontinuous, so we go from 0 to t of this guy. And let t then go to 1 from the left. And this is ln of x minus 1 minus ln of x plus 2, go from 0 to t. Okay, So at a 0 now, you see that limit of t goes to 1 minus. At 0, the first part is ln of absolute value of 0. That will give me good, ln of absolute value of negative 1, which will give me 0 minus ln of, oh, I should plug in t first. Sorry, ln of t minus 1 minus ln of t plus 2 minus, then plug in 0. The first one will be ln of 1, and then the second one would be ln of 2. Okay, so this way, when you find the limit, you notice that, oh, these guys, by the way, this is 0, that will be plus ln 2. There's no problem there. But and you look at this one, as t goes to 1, that will be ln 3. So there will be ln 3. Let us write this whole thing here. Ln 2 minus ln 3. How about this piece here? Ln of, don't forget the limit, ln of t minus 1. As t goes to 1 minus, this would give us ln of 0. Remember that the graph of ln is of this form. As you go to 0, from the right, this will go to infinity. So this limit here is going to be negative infinity. And since everything is just constant values, or other part of the limit, this will give us negative infinity. So what does this mean? This means that this part is divergent. When one of the parts, at least one of them, is divergent, then the whole thing is divergent. So this is divergent. I don't need to carry out and do the computation for the other one. This whole thing is divergent. Here I should tell you something, that if you didn't notice this middle point, and if you have gone with this, you could have evaluated at 2 and 1. So let me just, you could have done 2 and 1. And in that case, you will get into, 2 and 0, because the original integral. If you haven't noticed there is a discontinuity in the middle, you were in trouble, because you would have find something just number, but the whole integral is not continuous. So you have to be always careful with discontinuity of the integrand in the interval. Okay, how about this one? So we see that the function e to the power negative x 1 over x squared over x cubed is defined on negative infinity up to 0, and from 0 to plus infinity. Okay, so then it is an improper integral. It's an improper integral, and we should chop it up into two improper integrals with the end point discontinuity from negative 1 to, let me write it down, because I will come back to this and fill out. So from negative 1 to 0, that's where the discontinuity happens, and from 0 to 2. And now each one of these guys are discontinuous. We have to, improper, and we have to evaluate them. To be able to evaluate, so we have to first find antiderivative, or indefinite integral. So integral of e to the power negative 1 over x squared over x cubed dx. What you notice here is that the derivative of 1 over x squared is negative 2 over x cubed. And it is somehow here. You see 1 over x cubed is there. If I multiply this whole thing by negative 2 and divide it by negative 2, we have everything set up nicely, because this will give us e to the power u and du. Okay, so maybe I should write that down so that I have everything there. U substitution is u equal to 1 over x squared, then du is negative 2 over x cubed dx. And then when we change the, oh, there will be negative sign also there, yes. So this will give us 1 over 2 e to the power u plus c, which is half of e to the power negative 1 over x squared. Why did I find that? Because these are just, when you try to find integral from negative 1 to 0, what we do is we first turn it to a limit, an integral, and then the limit as t goes to 0 from the left, 0 minus. So this is limit of t goes to 0 from the left, half of e to the power negative 1 over x squared, go from negative 1 to t, but this will just give me limit of t goes to 0 minus of half of e to the power negative 1 over t squared minus half of e to the power negative 1. Okay, now as t goes to 0 from the left, then t squared will go to, so t goes to 0 from the left. As a result, t squared will go to 0 from the right. Then 1 over t squared will go to plus infinity. And then negative 1 over t squared will go to negative infinity. And limit of e to the power something, but when that something goes to negative infinity, is 0. So that will be half times 0. Well, let me don't write it, just write the final result. 1 over 2 over e. E to the power negative 1 is 1 over e, and I multiply it like that. So this part is convergent. So I see that this is convergent. And I have the value for that. How about the other part? So the other part, limit of the e to the power negative 1 over integral of e to the power negative 1 over x squared, x cubed dx. This is equal to limit of the integral from t to 2 e to the power negative 1 over x squared over x cubed dx. This is limit of t goes to 0 plus half of e to the power negative 1 over x squared t to 2. And this is limit of, okay, the first term will have no limit term. So it will be half of e to the power negative 1 over 4 minus limit of half of e to the power negative 1 over t to the power 2 as t goes to 0 plus. With the same argument up there, you will see that this limit also is 0. So the value that we found here is 1 over 2e to the power 1 over 4. So that means that, okay, so we have this one also convergent. Since both of these guys are convergent, since both parts are convergent, as a result, the whole integral is convergent. Sorry, convergent. And well, its value actually is the sum of the values of these guys, negative 1 over 2e plus 1 over 2e to the power 1 over 4. So that is the value of this improper integral, and the improper integral was convergent, and we were able to evaluate that. Okay, so that is the last part of for our improper integrals of type 2.